Do you feel the vibes?
So you can have an angle anywhere in space. Like right here, you can create an angle. However, if you take the angle and put it on the coordinate axes, right, inside a coordinate plane, then you can actually do a lot of, different types of measurements with it, right? So let's talk about what an angle is to begin with. So an angle, first of all, is formed by having a ray, first of all. So this is a ray. Now imagine if you clone that ray, right? So now there is like a second ray on top of it. And when you clone that ray, imagine you rotate it, okay? And then it stops at some point. So you rotate and then it stops at some point, and now you've created an angle, okay? The side with which you started, the initial ray that you started, is called the initial side, and the ray with which you ended is called the terminal side. Okay, so we're gonna take this angle and we're gonna put it on the coordinate plane. When the vertex, right? You guys know where the vertex is, this one, okay? In order for an angle to be in standard position, its vertex has to be at the origin, right here. The initial side has to lie along the positive x-axis, okay? And then the terminal side is obtained by rotating the initial side. Now, when you have the initial side on the x-axis right here, you can clearly rotate this way upwards, or you can rotate this way downward. So we don't call it upward or downward, right? In math, we call it clockwise and counterclockwise. So if you, like, remember those analog clocks with the hands, right? Clockwise is if it goes like the hands of the clock, and then counterclockwise is if it goes against the hands of the clock. In math and physics, the counterclockwise direction is always the positive direction. Okay?
If I'm just like given an angle, how am I supposed to determine which one the initial side?
That's what this is about. The initial side is always going to be on a coordinate plane from now on. And the initial side is always on the x-axis. Okay, so positive versus negative angles. All positive angles result from a counterclockwise rotation of the terminal side. So for example, here we start with the initial side. We rotate this way. You remember each corner is 90 degrees. You rotate that way. That's a positive 120 degrees for that angle. Negative angles, counterclockwise. So you start from the initial side, and then the second one that you're going to rotate is the terminal side. The terminal side rotates counterclockwise this way.
The highlighted thing is the terminal side?
No, that's the initial side, but the terminal side starts from there. There are two rays. Okay? So don't worry about that. Just worry, like you start from initial side, you go counterclockwise, it's positive. Now, if I start from the initial side, and if I rotate in the clockwise direction, then I get a negative angle of 145. Or whatever, a negative angle. This one happens to be negative 145. Again, from here to here, it's negative 90 degrees, and then I go a little bit more, and it's 145. So let's go ahead and draw these angles, and I'll tell you exactly what I'm looking for them if you would like to get full credit. So we want them in standard position. So we start here along the x-axis. Now, you have to show me which way you're rotating. We're going to rotate 210 degrees. So it's each corner is 90 degrees, right? So 90, 180, 210 is here. Okay? There. Okay, so do you see that? You have the arrow for the initial side. You have the arrow for the terminal side. You have the loop also with an arrow specifying direction. Some people, if this is the x-axis and the y-axis and they want to draw an angle of 210, they just do this. No, that's just a line, right? That's just some ray, diagonally in some corner of the coordinate plane. That is not what we're looking for, okay? Because it doesn't show rotation, none of it. Okay, negative 40 degrees. I start from here. I go clockwise here, right? So yes, we're going to eyeball a little bit. I'm not going to take my protractor and measure them. 45 degrees is halfway through that corner, right? So just eyeball 40 degrees. What I care about is what quadrant it's in. 470, I start here. If I go a full circle, how much is it? 360. So 470 minus 360, I need to go an additional 110. So from here, I go 90, 110, right here, there. Do you see the spiral? You got to show me the spiral. Okay?
You go through the arrow at the end?
No, like just stop. Yep. Okay. So, okay, let's talk about coterminal angles. Coterminal angles are two or more angles in standard position that share the same terminal side. Okay, so let's talk about this for a minute. Suppose I wanted to draw an angle of 60 degrees. Okay, I start here, rotate 60 degrees, boom. Okay, now suppose I wanted to draw an angle of 420 degrees. All right, 420 degrees. I start here. I'll go with the blue. I go 360. How much more do I need to go to make it 420? 60. And look at that. I end at the same place. Do you see that? So if it wasn't for the spirals, both the 60 degrees and the 420 degrees start at the same place, end at the same place. Seemingly, they could be the same angle. They are sharing a terminal side. They are called coterminal angles. Okay? Negative 300 is also coterminal with these. Okay? All right. So if I'm at this location, how would I go back to the same location? By adding how many degrees? 360 degrees, or by adding or by subtracting 360 degrees. So an angle that is coterminal with another angle can be found by adding and subtracting any multiple of 360. So I could add 360, another 360, another 360, another 360. Okay. So let's go ahead to example number 2. For each angle below, find one positive and one negative angle that is coterminal with the given angle. So for 210, for the positive angle, I say 210 plus 360, that's 570 degrees. You are looking for a positive coterminal angle. Is 570 a positive number? Yes. Okay, good. Negative 210 minus 360, it'll be negative 150. There, we're done. Okay, now, okay. So here we go. Negative 120. For the positive one, let's do negative 120 plus 360. How much is that? For the negative one, let's do negative 120 minus 360, negative 480. Okay, the negative one has to have a negative in front of it, okay? But now, suppose you had an angle of 460 degrees, okay? And you wanted a positive coterminal angle, right? You would do 460 plus 360, that's 820. Okay, now let's find, okay, that's straightforward. Now let's find a negative one. 460 minus 360, how much is that? 100. Okay, is that a negative number? No, just because you subtracted to get that number doesn't mean it's a negative coterminal angle. So you have to go one more time. You take the 100, you subtract 360 until you actually get a negative number. In this case, negative 260. So now, this is your negative coterminal angle. But if in getting to that from your original angle, you stopped by some positive ones, those also can work as a positive coterminal angle. So for example, both of those can work for the positive coterminal angle, right? Okay, so if along the way you pass some that fit, then it fit. Okay, so until now, you've always measured angles in degrees, right? Like in geometry, it's all in degrees. However, that's not the only way we can measure angles. Just like with height, right? You measure like somebody's height in the US and they could be 5'3". You measure somebody else's height in Europe and they're like 160 centimeters, right? Temperature, Celsius, Fahrenheit. So many things have multiple ways to measure, right? Or Kelvin even, right? Huh? Correct. 0.15.
Not according to Miss H.
Well, you tell her there is a 0.15 to go to Kelvin. Okay. 273.15. Yeah. Okay. So, so we know what the concept of degrees are, right? So if I had a perfectly circular pizza, right? Normally when you order pizza, it's cut into like 8 slices or 10 slices or whatever, right? So suppose you order a pizza and you say, hey, instead of the usual 8 slices, can you please cut them into 360 slices, right? So now let's visualize what that is, right? So, I mean, how thin would each be? I mean, it would be like a sliver, right? But each slice of the 360 would be 1 degree of pizza, right? So if you ate 5 slices, you've had 5 degrees worth of pizza, right? Which really isn't that much because there's 360 of them. So that's what a degree is. That's how tiny they are. Now, imagine we have another circle. Let's pretend this is a track. You know how like there's track and field? This is a perfectly circular track. You measure the radius of the track and it happens to be 10 meters. Now you're here, okay? And so you're here and now your coach says, okay, start walking. So you start walking and walking and walking and then they blow the whistle and you stop. You stop, you look at your steps, you've walked exactly 10 meters. Okay, now in the world of circles, this distance around the circle, a portion of the distance around the circle, do you remember what it's called? Arc length, right? Arc length. So now, okay, how much did you walk? 10 meters. What's the radius of the circle? 10 meters. What is the ratio of the amount you walked to the radius? 1. Okay, in getting from the original place to this place, do you see how you created an angle? Right? You walked a ratio of 1, right? 10 meters over 10 meters is 1. This angle that you created is 1 radian. Okay? Now, suppose you continue walking and the coach stops you at 20 meters. Now what's your ratio? 20 over 10? 2. That angle is 2 radian. Okay? Suppose you walk a little bit more. Why doesn't it? Let me do this. Okay. So suppose you walk a little bit more, 30 meters. How much is that angle? 3 radian. Now, suppose you walk a little bit more, and then something happens and your coach has to stop you, and you're like, oh my God, I was on a roll. And then you're like, oh, look, I walked half the circle. So you look, and you've walked 31.4 meters. What's the ratio now? Right, what is it? What's the ratio? What's the ratio? 3.14, which we know as pi. That's what pi is. That's why pi r squared. How much of the circle have we walked? Half the circle. How many degrees have we walked? Have we made? How many? 180. So we know that 180 degrees is the same as pi. And by the time you're at the middle of the circle, by the time you've walked the semicircle, the distance that you walked over the radius is always going to be 33.14. 22 over 7. Always, always, always. Okay? That's where pi comes from. All right?
That's why it says you can also add 2 pi.
Yep.
instead of just
Yep.
6.
Exactly. Exactly. So then, okay. So then, yep. So a full rotation around the circle takes us a distance equal to the circumference 2 pi r. So if I walked the entire circle, how much have I walked? Not 31.4, but basically 2 pi r. Divided by the radius, that's an angle of 2 pi. Do you see that? Isn't that cool? Isn't that the coolest thing you've ever seen in your life? Yes, it is. Okay? So I know. Well, this is the year. This is the year. This is when you're doing trigonometry. So this is really when you learn. Okay, but this is how the Greeks came up with it, right? Pi is the ratio between the circumference and the diameter of a circle. That's why, right? Circumference pi times diameter. Now it makes sense. See, now it makes sense. Okay, so what you need to remember is 180 degrees is equal to pi. And this is one of the reasons why I love teaching trigonometry, because of this moment when students are like, oh my God, that is the coolest thing ever, right? 180 and pi. Okay, and so I always like to go through this like circular track example. Okay. Okay. Huh? Just clicked. Okay, good. So now let's do this then. So this is 0, okay, radian. By the time I make it fully around the half of the circle, it's pi radian, correct? It's pi. And then if I go here, when I'm up at the top here, that's half the distance from 0 to pi, so that's half a pi. That's pi over 2. Okay? In degrees, what would all this be? This would be 0 degrees, 90 degrees, 180 degrees, 270, and 360. Okay? But now in radian, it's 0, pi over 2, pi. So each corner is pi over 2, half a pi. Half a pi, half a pi. By the time I get to 270, it's 3 corners. Pi over 2, pi over 2, pi over 2. So it's 1 pi and a half. So that's 3 pi over 2. No, because that's actually the most misleading thing ever, because a pi in math is half a circle, but a pi, like an apple pie, is a full circle. So whenever I'm talking about, I never actually use the example of a pie. Like I'll use a chocolate bar or something, because a pie is misleading. There's lots of things, right? 20 years and plus teaching math, you learn things. So we don't, right? It's like, right. Okay. 3 pi over 2.
So let me get 2 pi of pizza.
Right. Right. Yeah. Can I get a pizza? Please make it 2 pi. That's a circle.
Then if they charge me for 2, then they're wrong.
Then they're wrong. Exactly. See? But please don't go trying people's like math knowledge. Please, Justin, you will be very disappointed most of the time. Okay. So then by the time we get around here, it's 2 pi. Okay. Now, there is some other things we could do. Okay. So the equivalent in decimals of pi is how much? You know this. 3.14. So here, this angle is 180 degrees. In radian, it's either pi or 3.14. It's the same thing. Okay. So now, if I'm at pi over 2, then it's 3.14 divided by 2, 1.57. At the bottom, 3 over 2 pi, 1.5 times 3.14 is 4.7. And then by the time you're here, that's 2 pi, 2 times 3.14, 6.28. So now, let's think about this for a minute. We know about the quadrants, right? 1, 2, 3, 4. Okay, this is very important to get sense of this. If I tell you there is an angle of 140 degrees, which quadrant is it in? 1, 2, 3, 4. 140 degrees. 2. Okay, if I tell you 300 degrees, 4. Okay, if I tell you pi over 4, quarter of a pi, 1, quarter of a pi, 1. Okay, if I tell you 2.1 radian, where would it be? 2. 1.57, 3.14, in between. 2.1 radian is over here. Okay, how about 4 radian? Where's 4 radian? 3. 4 radian is 3. Okay, it's kind of confusing, so you have to go with this. 3.14, half of it is 1. Okay, so where is half a radian? 1 in quadrant 1. Where's 5 radian? 4, quadrant 4. Okay, so more of that. You'll get so comfortable with this. I promise you there will be a point where you will prefer to work in radian and not degrees because it's so much easier. I promise.
So that one's
Okay.
90 and pi over 2. What's the
90 degrees and pi over 2 are the same.
So then what is
1.57. Because it's 3.14 divided by 2. Yeah, half of pi, half of 3.14. It's 3 over 2 pi, 1.5 times pi, 1.5 times 3.14. Okay, so what we need to remember right now is that pi is equivalent to 180 degrees. Half the circle, pi, 180. So that's how we can convert between degree and radian. So let's write the following degree measures as, okay, so I have this here. This is something that I don't want you to memorize. Multiply by this, multiply. Don't memorize that. All I want you to memorize is the circled 180 and pi are equivalent, okay? So here, just know that 180 degrees and pi radian are equivalent. So when it says to write as radian, you know how to convert, right? It's always, anytime you're converting units, it's times and a fraction bar. Now, here, 135 degrees, degrees is in the numerator. So over here, I got to put degrees in the denominator, so they cancel. That means pi goes on top, huh? Huh? It's like stoichiometry, because stoichiometry is just unit conversion. Okay? All right, yes, instead of grams per mole, you just do degrees over radian, and right? Exactly. Okay, so now you can divide both of these by 45, so you get 4 and 3. 3 pi over 4. Negative 270 times and a fraction bar.
Oh, we're not supposed to like.
No. Okay, listen. These, when it says in radian, leave it in terms of pi. Okay, 180 goes here, pi goes over here. The zeros go away, and then you can divide by 9. So negative 3 pi over 2. Okay. Now let's convert these. Okay, now we have pi in the numerator. Pi goes here, 180 goes there. They cancel. I got 60, so this is negative 120. Times 180 over pi. Pi's go away. 4 and 180, they're it's a factor of 45. Okay, and so now, do you guys know how to multiply? This will be a non-calculator section. So do you know how to multiply 45? Do you know how to multiply a 2-digit number by 11? So if it's 45, you put the 4, you put the 5, you add the 2, 9, that goes in the middle. Okay? Any 2-digit number by 11. Yeah, that is cool. Okay. Huh? You learn something new every day. Well, hopefully you're learning more than one new thing today. Okay. Okay. Now, okay. So up here, let's talk about coterminal angles again. I purposely didn't go the full sentence here. to find an angle that is coterminal, you either add or subtract a multiple of 360 or in radian 2 pi. Okay, so yeah, I purposely left that behind. Okay, so here to find the positive angle, we're going to do 2 pi over 3 plus 2 pi, 2 pi over 3 plus 6 pi over 3, 8 pi over 3. No, you guys don't. 2 pi, it's 2, right? This is over 3, so 6 over 3 is 2. Yeah? Okay, so the negative coterminal angle, 2 pi over 3 minus 2 pi. So this is 2 pi over 3 minus, okay, 2 pi is 6 pi over 3, right? 2 is 6 over 3. So 6 over 3 pi. This is negative 4 pi over 3. Yeah. Mm-hmm.
How is 2 pi plus 2 pi 2 pi plus 6 pi?
No, it's 2 pi over 3.
Sorry.
Okay.
Oh.
2 is 6 over 3. Okay. Now look. Take a look at this one. For the okay, so negative 9 pi over 4 plus 2 pi. Okay, so you can do it. So this would be 8 over 4 pi, right? I have a quicker way of doing it in my mind. When I'm adding any fraction with any whole number, I know that the common denominator is going to be a 4. So here's what I do. This times that is what? 8 pi plus negative 9 pi, negative 1 pi over 4. Exactly. So that's negative pi over 4. You can do it that way, or if you don't want to do it that way, do it the other way. Okay. Is this a positive coterminal angle? No. So I got to do it again. Negative pi over 4 plus 2 pi. Let's do the same thing now. Over 4. Yep. This times that. This is 8 pi. When you add negative pi, 7 pi over 4. So this will be the negative. This will be the positive. Huh? No, because all you need is one negative. All you need is one positive. Okay. Question. So look. Here we have 0 to 2 pi. Correct? So from 0 to half the circle, it's pi, right? And then we cut that in half and we got pi over 2. However, if you have this, right now, oh, I know. Oh my God, I literally never knew you could do that. Okay, if you have that, you don't, oh my God. So we just cut it in half right now, but you don't have to just cut it in half like once, right? You can divide it more than one time, correct? So for example, okay, this is quadrant 2. So the first quadrant here goes from 0 to pi over 2, right? So this is half a pi, but half isn't the only division you can make. Like if you have a chocolate bar, you can cut it in half. You can cut it into thirds. You can cut it into fourths, right? So this thing over here, if I cut this much of it, half of the half, that would be a fourth, right? Or if I can cut it, let's say, into here. If I do this and this, now I've cut it into 1, 2, 3 pieces into thirds, right? So I can also do it that way. So now take a look at this one. Take a look at this. Let's go back to this page. Okay. This much over here is 1/6 of the pi, right? 1/6 of the half circle. Okay. Now, so this is pi over 6. Okay. How much was pi in radian? I'm sorry, in degrees? 180. So pi over 6 is 180 over 6, which is 30 degrees, right? Yes? So this is the equivalent of 30 degrees. So if you make that line, then here you have the equivalent of 30 degrees away from the x-axis that way. This is equivalent of 30 degrees away from the x-axis here, and this is equivalent there. So each of those angles are an equal measure away from the x-axis, correct? And that measure happens to be how many degrees? 30 degrees, which in radian is how much? Pi over 6. So now, this radian business is like a clock. So you have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Okay? So now, all of these have to have over 6. Okay? Because they're equivalent. So now, take a look at what I've done over here. These are all of the coefficients of pi over 6. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Look at the pi over 6. They cancel. Does the 6 stay a 6? No. So I don't want to use that. Here, these also cancel. These also cancel. The next one that doesn't cancel is 5 pi over 6. So this one is 5 pi over 6. What's the next one that doesn't cancel? 7 pi over 6. And the next one? 11 pi over 6. And then what would 12 pi over 6 be? 2 pi, which you've completed a circle. So now look here. 1 pi over 6, right? 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7, 8, 9 pi over 6, 10, 11 pi over 6, 12 pi over 6. It's literally like a clock. So you have to know pi over 6 is like the 30. They're the ones closest here. And then it's the ones that don't cancel with the coefficients. Because pi over 6 is 180 over 6, an equivalent of 30 degrees. Right? Pi over 6 is 180. Okay, so now, how about the pi over 4s? These are all the pi over 4s. What is that equivalent to? 180 over 4, which is 45, right? Because it's half of the half, which is a quarter. So this first one is pi over 4. And then does 2 pi over 4 cancel? Can't use that. Does 3 pi over 4 cancel? No. 4 pi over 4 doesn't work. 5 pi over 4 works. 6 cancels. 7 pi over 4 does not cancel. What's 8 pi over 4? 2 pi. So we just made a full circle. So if you're walking down the street and somebody says, hey, tell me the pi over 4 equivalents, you're like 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay? All right, let's do the last ones, the pi over 3s. Okay. Pi over 3, if you ever get confused, how much is pi in degrees?
180.
What's 180 over 3?
60.
Okay, so these are all the ones that are 60 degrees away from the x-axis. In trigonometry, it's all about the x-axis. Nobody cares about the y-axis. Like, it doesn't even exist. Okay, so this one is pi over 3. 1 pi over 3. Does 2 pi over 3 work for us? 3 pi over 3? 4 pi over 3? How about 5? How about 6? Because you want them to be pi over, so because if you have 3 pi over 3, that's actually pi. That's not an equivalent of, that's 180 degrees. That's not an equivalent of an angle that's 60 degrees away. You see that? And if we have like, yeah, if it can be simplified, then it's not. So let's go over here. So hang on. If I have 4 pi over 6, What is that? 2 pi over 3. But see, 2 pi over 3 is this angle. You see that? It's 2/3 of a pi, you know, which is over here. Okay? So that's why the ones on these lines are all the pi over 6s. The ones on these lines are all the pi over 4s. And then these are all the pi over 3s. Okay? And this is where we're going to stop today. Okay? So if you look on your lesson plan, for the following day, we have a little bit of this and the new lesson. But I wanted to get at least this much in.